Welcome. This is Computer Programming 1 from the University of Washington. Or maybe I should say, this has been Computer Programming 1 from the University of Washington. We've reached the end of the course. I'm Martin Dickey. I've been your guide through this course. Today I'd like to wrap up with a look back at what we've done. And I'd like to start by looking ahead to where you might go having successfully completed the course. What you do next might depend on what your goals are. Let me share with you what the next step would be if you were a student on campus at the University of Washington. There, the next course in this sequence is called CSE 143, Computer Programming 2. It's a direct continuation of the course which this series has been based on, CSE 142. CSE 143 introduces the C++ programming language. At many universities on the semester system, the second semester course has a title like Data Structures. The course CSE 143 at UW is 5 credit hours. It has 4 to 5 major programming projects and includes writing fairly complicated programs that might include as many as 15 or 20 individual source files. Students who take the course often report that it's intensive and time-consuming. And this is a frequent reaction to courses at this level. The language in that course is C++, which initially is just like C. Gradually we introduce concepts which are new in C++, and eventually we learn about combining the basic algorithmic knowledge of C with a new approach called object-oriented program. This involves the notion of objects and classes. In a typical second course, such as CSE 143 or similar courses at other universities, you get lots of programming practice, but much less class discussion of the programming details. You do much more work with data structures, and many of these may involve references or pointers. Sometimes the notion of an abstract data type will be introduced in order to discuss aspects of data structures. Algorithms is another focus of courses like this, and many algorithms will be recursive. Problem solving and design continues to be a concern in all courses of this level. They are intended to serve as a foundation for later CS courses that might be in more specialized areas. If your interest is to go on in the C language, let me tell you that there are many parts of C we haven't covered, that we haven't even tried to cover. But with the concepts you now know, you're in a very good position to master these more advanced C programming features. Now, whether or not you learn more C may or may not be useful. It depends on what your goals are beyond learning C. The advanced features you learn of C may not necessarily help you learning other languages. Perhaps you're interested in going on to C++. If so, you're in good shape. C++ was developed as an extension to C. Just about everything we've done in this course can be used in C++. And in all but some very rare exceptions, the syntax is exactly the same. But C++ does include some important new concepts which are not in C at all, and, as we learn in 143, lead to an approach called object-oriented programming. Java is another popular choice for software development these days. Java is in many ways an improved C++, and much of its syntax is close to what we learned in C. Basic statement types such as if, while, and for, and the way expressions are formed and evaluated. However, Java is not quite as close to C as C++ is, and Java, like C++, contains many new features to support an object-oriented view of the world. In this course, we studied some details of C programming, but the concepts that we learned go far beyond the C language. Let's just review the major concepts. Variables and the notion of data types and values. The idea of conditions and conditional execution, for which we saw more than one type of statement. Loops And an alternate way of doing repeated parts of algorithms, recursion. Functions were a very important part of the course. There are many technicalities involved with functions, including parameters, pointers, and the call-return mechanism, besides which functions were a fundamental building block in structuring our algorithms. We also talked about structuring data using arrays, structs, and combinations of those. Finally, we talked about input and output, surely an important concept in all aspects of computing. Beyond programming, we saw glimpses of other areas of computer science. We talked about some compiler concepts, the notion of syntax compared to semantics, the steps in compilation and program preparation and debugging. One thing I hope very much you'll carry away from the course is an improved idea of what a computer is, a better mental model that you can apply to situations involving computers. Now you may be able to visualize the memory, the CPU, and the I/O operations as the computer is operating. The instruction execution, the flow of control, and the movement of data in and out of the computer. Problem solving is an essential part of applying our knowledge. Abstraction is an important concept which leads to notions of functional decomposition as well as data decomposition. Perhaps the most fundamental notion of all is that of an algorithm. At the beginning of this course, I shared with you some of my own goals for what I hoped you would gain from this course. Let's review what those were. I hoped that by following this course to its conclusion, you would have a solid foundation in the technical basics of C programming. If you have a foundation you can apply to further studies in programming and in computer science. Along the way, I hope you've developed a feeling for what computer science is. For example, for some of the complexities involved in creating large computer systems. Computer programming can be very frustrating or challenging, but it can also be very enjoyable. It can and should even be fun. I hope you found that to be the case. Happy programming.